Hello viewers, this is Wagadaro now taking you through today's tutorial on how to derive and use the equation of trajectory in projectile motion. So equation of trajectory is an equation for the path described by a projectile. For example, if a particle is projected with a velocity u at an angle theta to the horizontal, it will take this path. So this path is known as the trajectory, and the equation for this path is known as the equation of trajectory. So in this case, we shall consider horizontal displacement at any time t to be x and the vertical displacement at any time t to be y. In other words, sx will be considered to be x and sy will be considered to be y. So we shall get an equation relating x and y, and that will be our equation for this path, known as the equation of trajectory. We shall start with horizontal motion. So using the second equation of motion for horizontal motion, we shall come up with sx equal to uxt plus a half at squared. So a is 0, meaning the whole of this goes away, becomes 0, and ux is u cos theta times 2, which is that. Sx is x, as we said here. Therefore, we shall come up with our x equal to ut cos theta. So that is one equation for x. We also need to get an equation for y. Then we see how to relate the two. So using second equation of motion for vertical motion, we shall say sy is equal to uyt minus a half gt squared. So in this case, y is equal to ut sin theta minus a half gt squared. So you have got two equations, one for x and one for y. So you have to relate the two. In this case, we can do it easily by eliminating t. You see, t is common in both. So making t the subject t, I shall come up with t equal to x over u cos theta. Substitute it where there is t in this equation for y. We shall get y equal to u open brackets x over u cos theta, which is the value of t, times sin theta, minus a half g in brackets x over u cos theta, which is t squared. But you have to remember that sin theta over cos theta gives you tan theta, and 1 over cos theta gives sec theta. So in this case, sin over cos will give you tan, u over u it will cancel, and this cos, which is the denominator, can become the numerator by making it sec theta, as we have done in this step. So u has gone away, sin over cos has become tan theta, and this cos has become sec theta. But we also know that sec theta, when you square it, you get 1 plus tan squared theta. So when you substitute that in this part, we shall be able to come up with y equal to x tan theta minus gt squared in brackets 1 plus tan squared theta close brackets everything over 2u squared. So this is what we call the equation of trajectory. Now problem 1 says the stone projected from a point O on the horizontal ground moves freely under gravity and hits the ground again at point A, taking O as the origin, OA as the x-axis, and the upward vertical at O as the y-axis. The equation of the path of the stone is given by 40y equal to 40x minus x squared, where x and y are measured in meters. Calculate Roman 1, magnitude and direction of the velocity at O. Roman 2, greatest height above OA attained by the stone. Roman 3, distance OA, and Roman 4, time taken by the stone to reach A from O. So in that case, let the particle be projected with a velocity u and at an angle of theta. So this is the equation of this path taken by the particle. Remember they said OA, we take it as the x-axis, and the vertical through O as the y-axis. So what you shall do, you have to compare that equation of the path or equation of trajectory with the general equation of trajectory. So when you compare, we shall come up with x here, the equation of x here is 1, coefficient of x here is tan theta. So when you equate the two, you come up with theta as 45. Do the same for the coefficient of x squared. This is 140. For this it will be this over that. So come and equate the two, which is that. We know that tan theta is equal to 1, so substitute 1 here, which is that. And g is 9.81, so substitute 9.81 there. So this 2 will cancel with this 2, so numerator will just remain 9.81, and denominator will just be u squared, just as it is in this step. So when you cross multiply, you shall come up with u squared as 40 times 9.81. Make sure the subject, you shall get square root of 392.4, which gives 19.8091 meters per second. Therefore, the initial velocity of the particle at point O is 19.8091 meters per second in the direction 45 degrees above the horizontal. Roman 2, they wanted the maximum height, is given by the formula u sin theta, everything squared, over 2g. So u is square root of 392.4 and theta is 45, g is 9.81. We shall get 10 meters, and that will be the maximum height attained. Roman 3, they wanted the distance OA. So come to the equation of trajectory, equation of the path. So distance OA is got when, remember this is an x-intercept, so it's got when y is 0. At that point O and A, y is equal to 0, so substitute for y equal to 0. In this case, x is common, factorize it out. Therefore, either x is equal to 0 or 40 minus x equal to 0, giving you x equal to 40. So at x equal to 0, the particle is at point O. At x equal to 40, the particle is at point A. Therefore, distance OA is equal to 40 meters. They also wanted the time taken to reach A. So in that case, OA is equal to ut cos theta. So OA is 40, u is known, 19.9091, t is what we want, theta is 45 degrees. So make sure the subject will come up with 2.8557 seconds. That has been the solution for problem 1. Now problem 2, a particle is projected from a point A with an initial velocity of 60 meters per second at an angle 30 degrees to the horizontal. At the same time, a second particle is projected in opposite direction with initial speed 50 meters per second from a point level with A and 100 meters from A. If the two particles collide, find Roman 1, the angle of projection of the second particle, and Roman 2, when the collision occurs. So this will be the sketch. The first particle at A is projected with a speed of 60 at an angle 30 degrees to the horizontal. Second particle is projected with a speed of 50 at an angle which is unknown, so let it be theta. Then let them collide at this point whereby the vertical height is y and the horizontal distance covered by A will be x1, horizontal distance covered by B will be x2. Since the distance apart is 100, it means that x1 plus x2 will be equal to 100. So considering vertical motion, y will be equal to ut sin theta minus a half gt squared. Using that for particle A, we shall come up with y equal to 60t sin 30 degrees minus a half times 9.81 t squared. When we simplify that, we shall come up with this equation, call it equation 1. Then for particle B, y equal to 50t sin theta minus a half times 9.81 t squared. When you simplify that, we shall come up with this equation, call it equation 2. So both equations have the same value for y, so meaning we can equate the two. So shall equate the two, equation 1, equation 2. After equating the two, you realize that this component is the same as this component, meaning it can cancel to give you that. And still further, t and t can cancel, and 30 and 50 have 10, which is a common factor. So in that case, we shall remain with 3 equal to 5 sin theta, giving us theta as 36.8699. Using the horizontal component, x will be equal to ut cos theta. So in that case, remember x1 plus x2 is equal to 100. So x1 will be the horizontal distance covered by particle A, and to be given by u, which is 60, and theta, which is 30. x2 is the horizontal distance covered by particle B, to be given by u, which is 50, and theta, which is 36.8699. So when you substitute and equate it to 100, you shall come up with this. You shall realize that t is common in both. So factorize it out, you get this. When you make t the subject, you come up with 1.0874 seconds. So that brings us to the end of today's lesson. Thank you for watching, and please subscribe to my channel, Rowa e-learning platform.